Hey guys, today we're going to learn how to find the area between two curves. So here we have a graph of two functions. We have f of x is negative x squared minus x plus 2, and g of x is equal to x plus 2. So first you need to be able to identify which function belongs to which curve. This one here, the negative x squared, that's going to be the parabola. So this one here is f of x. And then x plus 2 is the linear function, so this blue one here is g of x. First, we're going to find the value of the integral from negative 2 to 0 of f of x dx. So that means that I'm going to take my function here, f of x, and I am going to integrate that. When I integrate, remember that we're adding 1 to the exponent and then dividing by the new exponent. So this is equal to negative x to the third over 3 minus x squared over 2 plus 2x, and I'm going to evaluate that from negative 2 to 0. When I plug in the 0, everything is going to end up being 0 because all the x's. So 0 minus, now when I plug in the negative 2. Negative 2 to the third is negative 8. And then we have the negative on the outside, making it a positive 8 over 3. Minus, negative 2 squared is positive 4, divided by 2 is 2. Plus 2 times negative 2, which is negative 4. Now I'm going to combine these. So 8 over 3, oops, forgot the negative here on the outside. Negative 2 minus 4 is negative 6. We're going to need to put this over a denominator of 3, so I'm going to put this over 3 and multiply this by 3. So we have negative 8 over 3 minus 18 over 3, which gives me negative 10 over 3. So my final answer here is 10 over 3. Now what this represents on the graph is this part here. So we just did from negative 2 to 0 underneath the curve of f of x. So it's this section here. All of this area represents 10 over 3. Now let's do g of x. Find the value of the integral from negative 2 to 0 of g of x. So I'm going to integrate from negative 2 to 0 the x plus 2. When I integrate that, that's going to give me x squared over 2 plus 2x. And again, I'm going to evaluate that from negative 2 to 0. Plug in the 0, everything will be 0. Minus, now when I plug in the negative 2, negative 2 squared is 4, divided by 2 is 2. Plus 2 times negative 2 is negative 4. So we have negative 2 minus 4 is negative 2, and negative 2 gives me positive 2. So what this represents is this section here. So that's from g of x, so that's everything below g of x. So that's this triangle here, which we could have also found this area by just getting the area of the actual triangle. Now for our end goal is to find the area between the two curves, meaning this section here. This is what's in between them. It's between f of x and g of x. So in order to get that particular area, what we're going to have to do is we're going to subtract the area of f of x minus the area of g of x, and what that gives me is that leftover area in between them. So I'm going to do 10 over 3 minus 2, which I need to put that over 3, and I get 10 over 3 minus 6 over 3, which is equal to 4 over 3. So this is a way that you can find the area between two curves. You get the area of the higher function, you get the area of the lower function, and then you're going to subtract the two. However, there is a little bit of a shortcut. In order to get that area without having to find each integral individually, you can actually subtract your functions first. So and then you integrate. So basically you're doing the high function, so the one that is taller, right, the one that's above the other, minus the low function, the one that's below it, and that's going to give you that area in between. So let's try that out with the same exact functions that we had before. We're going to do f of x, which if you notice on your graph here, f of x is the higher function, minus g of x first, and then we'll integrate and get our final answer. So I'm going to do the integral from -2 to 0 of f of x, which is negative x squared minus x plus 2, minus g of x. So notice that I open my parentheses when I'm going to subtract g of x, because I need to keep in mind that I am subtracting the entire function. When I distribute this negative, I get the integral from -2 to 0 of negative x squared minus x plus 2 minus x minus 2. I can combine my like terms, the 2's here will cancel, and I can combine these negative x's. So my integral is now from -2 to 0 of negative x squared minus 2x dx. Now I'm going to integrate and evaluate. When I integrate that, I get negative x to the third over 3 minus 2x squared over 2 is x squared. And this is where I'm going to plug in the -2 to 0. Plugging in the 0, I get 0. Minus, when I plug in the -2, -2 to the third is -8, and then the negative on the outside makes it a positive 8 over 3, minus -2 squared, which is 4. I'm going to need to subtract this, so I'm going to put this over 3 and multiply this by 3. So I have negative 8 over 3 minus 12 over 3, which gives me negative 4 over 3. And so our final answer is 4 over 3. And you see that here I got the same thing that I got as my final answer when I subtracted. So it's a little bit easier because now instead of integrating twice, you only have to integrate once. Now let's try that again here. We have these two curves. We want to find the area between them from x is equal to 1 to x is equal to 3. What this means is that we are going to get this area here. So the top minus the bottom from 1 to 3. So we're going to set up our integral is from 1 to 3. Now to figure out which one is the high function and the low function. One, you can look at, first of all, these are both parabolas because they're both quadratics. The numbers that are attached to the x squared can determine how thin my parabola is. The higher the number, the thinner the parabola is. So this 2x squared, I'm going to call this one y1. This is y1 here. And then this one, which is 1/2 x squared, is not going to be as skinny as the other because it's 1/2 is less than 2. So this one here would be y2. Another way to distinguish between these two functions is by this number here. This is the y-intercept. So here, this would be a y-intercept of 10, which even though we don't see the graph, you can see that this is going to keep going up and it's going to hit the 10 and the y-axis. And then here, the y-intercept is -1, which you can see here on this graph. The y-intercept here is -1. So that's another way of distinguishing between the two functions. So I'm going to do my high function, which is y1, minus the low function, which is y2. Let's distribute this negative so then we can combine our like terms. So this is the integral from 1 to 3 of 2x squared minus 8x plus 10 minus 1/2 x squared plus 2x plus 1 dx. Now we're going to combine 2x squared minus 1/2 x squared. If I put this over 2 so I can subtract, this is 4 over 2x squared minus 1/2 x squared, which is 3 over 2 x squared. Then we have negative 8x plus 2x is negative 6x. And 10 plus 1 is plus 11 dx. Now I'm ready to integrate. So this would be 3 over 2 x to the third over 3 minus 6x squared over 2 is 3x squared plus 11x. And I'm going to evaluate that from 1 to 3. Here I can simplify this because I have this 3 in the numerator, this 3 in the denominator, so they will cancel. So this is x to the third over 2 minus the 3x squared plus 11x. And now I'm ready to plug in the 3 and subtract when I plug in 1. When I plug in 3, 3 to the third is 27 over 2 minus 3 squared is 9 times 3 is 27 plus 33 minus, now when I plug in the 1, 1 to the third is 1 over 2 minus 3 times 1 squared is 3 plus 11 times 1 is 11. We can combine here these whole numbers and then distribute the negative. So we would get 27 over 2, negative 27 plus 33 is plus 6, minus 1/2, negative 3 plus 11 is plus 8. Distribute this negative. We have 27 over 2 plus 6 minus 1/2 minus 8. We can combine 27 over 2 minus 1/2 is 26 over 2, and 6 minus 8 is minus 2. 26 divided by 2 is 13, and 13 minus 2 gives me a final answer of 11. So that's how you can do our area between two curves. Let's try that with another example. Find the area of the shaded region R that is bounded by y equals sine of pi x and y equals x to the third minus 4x. So first, if we're going to find the area between these two curves, notice that in this question, they don't give you the limits of integration, what I need from here to here. Here I was given those limits because my functions did not intersect. So you would need to know where to start and where to end. However, the area here for region R, it starts here at 0 where my functions intersect until here where they intersect again, which is at x is equal to 2. So these are going to be my limits of integration from 0 to 2. And now I'm going to do my high function minus my low function. Sine of pi x, that is a curve, or it's a wave. So basically, I already know that it's going to be this part here of my graph. So this one I'll call y1. This top one is y1. That's sine of pi x. Then y equals x cubed minus 4x would be this one down here. So this is y2. So I'm going to do the sine of pi x minus x cubed minus 4x. Don't forget to put parentheses around the second function so that we can remember to distribute that negative. So this is the integral from 0 to 2 of sine of pi x minus x to the third plus 4x dx. Now we're ready to integrate. Just to make it easier for you to see, I'm going to separate these integrals so that we can see how to integrate this sine of pi x. This is the integral from 0 to 2 of sine of pi x. And then we have this separate part here. I'm just going to do this part first and then we'll continue with the rest. So this here, because we have a pi x as part of the angle, I am missing the derivative of pi x, which is pi. Meaning I'm going to have to divide pi on the outside. So this particular integral would be 1 over pi, and then I'm only going to integrate the outer function, which is sine, which is negative cosine, and then we leave the pi x alone. Now I can continue to integrate this part here, which would be negative x to the fourth over 4 plus 4x squared over 2, which is 2x squared. And this is what I'm going to evaluate from 0 to 2. So I'm going to plug in the 2. We have negative 1 over pi cosine of 2 pi minus 2 to the 4th is 16 divided by 4 is 4 plus 2 squared is 4 times 2 is 8 minus when I plug in the 0. So this would be negative 1 over pi cosine of pi times 0, which is 0. And then all of this is going to end up being 0 anyway. Now let's evaluate. The cosine of 2 pi is 1. So this is negative 1 over pi times 1, which is negative 1 over pi, minus 4 plus 8 is plus 4. Here I can distribute, so this will be plus 1 over pi, and the cosine of 0 is also 1. So what ends up happening here is the negative 1 over pi and the 1 over pi will cancel, and I'm left with my final answer of 4. Now let's look at our final example. Here we're going to try to find the area between two curves that have multiple points of intersection. So first, let's identify our graphs. I'm going to label this equation here as y1 and this one as y2 so I can identify it easily here. The first one is negative 1/2 x to the third plus 2x squared, and then we have negative x squared plus 4x. So because these are different degrees, I know that this is a cubic function, so that's going to have more curves than the quadratic. So this one here, the blue, is y1. And the red, that's my parabola that's upside down, so that is going to be y2. So you can see if we're trying to find the area between the two curves, we have two separate sections. We have this section here, and then we have this section here. We're going to have to do these areas separately, simply because from 0 to 2, my high function is the parabola, versus from 2 to 4, my high function is the cubic. So we're going to set up two integrals to find this area. The first one, and again, we're using those points of intersection. For the first section, it's from 0 to 2. And then it's the parabola minus the cubic. So it's y2 minus y1, which would be negative x squared plus 4x minus this function here, which is the negative 1/2 x cubed plus 2x squared. That's for the first section. Now I'm going to add the second section. So that's a separate integral. That's going to be from 2 to 4, but now my cubic function is on the top, so that's going to go first. Negative 1/2 x to the third plus 2x squared minus, and the low function, which is my parabola, the negative x squared plus 4x. Now this is going to take a little bit of work. We have to distribute this negative here and distribute this negative here, and then combine our like terms. So we have the integral from 0 to 2 of negative x squared plus 4x minus 1/2 x to the third minus 2x squared plus the integral from 2 to 4 of negative 1/2 x to the third plus 2x squared plus x squared minus 4x. When we combine our like terms, we have, first let's put them in standard form, meaning I'm going to go in order of exponents. So I'm going to start here with this negative 1/2 x to the third. Then negative x squared minus 2x squared is negative 3x squared plus 4x. Plus the second integral, which is from 2 to 4. We're going to start with the negative 1/2 x to the third. Oh, this is supposed to be, I just realized, here this is supposed to be a plus 1/2 x to the third. I forgot to distribute the negative here in the front. Okay, now that we're set up, negative 1/2 x to the third, and then we have 2x squared plus x squared, which is plus 3x squared, and then minus 4x. The integrals here look very similar. The only difference is that the signs are different. But regardless, we still need to evaluate each one separately because those limits of integration are different. So let's go ahead and integrate. So when we integrate here, we have 1/2 x to the fourth over 4 minus 3x cubed over 3 is x cubed plus 4x squared over 2 is 2x squared. Plus, now I'm going to integrate this one here. So this is going to be negative 1/2 x to the fourth over 4 plus 3x cubed over 3 is x cubed minus 4x squared over 2 is 2x squared. And this one I'm going to evaluate from 2 to 4. And what I like to do here is I like to put these in brackets just so that I can distinguish one evaluation from the other. So now what I'm going to do, just to conserve on some space, I'm going to erase the top and I am going to clean up my work here so that way I can start plugging in the numbers and get our final answer. So 1/2 x to the fourth over 4 is x to the fourth over 8 minus x to the third plus 2x squared evaluated from 0 to 2 plus, and then over here is negative x to the fourth over 8 plus x cubed minus 2x squared, and this one is evaluated from 2 to 4. So now I'm going to erase this one here because I've rewritten my integral. All right, let's go ahead and start plugging in. When I plug in the 2 to the fourth is 16, divided by 8 is 2, minus 2 to the third is 8, plus 2 squared is 4 times 2 is 8, minus, when I plug in 0, everything will end up being 0, plus. Now I'm going to plug in the 4 and then the 2. So when I plug in the 4, and here I'm going to eliminate the bracket because now I'm already starting to do my evaluation. This would be negative 4 to the fourth. 4 to the fourth would be 256, so negative 256 over 8 plus 4 to the third is 64 minus 4 squared is 16 times 2 is 32. Minus, now when I plug in the 2 to the fourth is 16 divided by 8 is 2, so, and then it's negative, so negative 2 plus 2 to the third is 8 minus 2 squared is 4 times 2 is 8. So we can start eliminating some things. Here, this 8, this negative 8 and this plus 8 will cancel out, and then this 8 and this negative 8 will also cancel out. So let's see what else we have. We have 2, and then here this negative 256 divided by 8 is negative 32 plus 64 minus 32, and then here if we distribute this negative, this would be plus 2. Now negative 32 plus 64 minus 32, all of this cancels out because negative 32 with negative 32 is negative 64, which will cancel out with the positive 64. So then we're left with 2 plus 2, which is our final answer of 4. And that's how you find the area between two curves.